Welcome to the AI Research Roundup. I'm Alex. Today we're looking at a paper trending on X, published on November 4th, 2025, about 5 days ago. This paper introduces EPaxos star, a simpler and correct leaderless replication protocol that preserves the fast to-message path, fixes recovery bugs and deadlocks, and improves optimality by reaching F-resilient and E-fast operation, with the minimum processes N being at least the maximum of 2E plus F minus 1 and 2F plus 1. The paper is titled, Making Democracy Work, Fixing and Simplifying Egalitarian Paxos Extended Version. And as we'll see later, the implications for real systems are quite significant. Alright, the introduction set up the dependency graph idea and the key invariants. Figure 1 presents the execution protocol, which scans for the largest set of committed commands, whose dependencies are also committed, then processes that set. The code splits the graph into strongly connected components, which are groups where every command can reach every other, and orders those components topologically. Within each component, commands run by identifier, skipping NOPs, so cycles get resolved deterministically. Well, Figure 1 outlined how execution batches ready commands. Figure 2 illustrates why that works with a concrete dependency graph. Figure 2 shows 4 commands where C1 points to C4, C2 and C3, and C2 and C3 point to each other. The graph yields 3 strongly connected components, C1, the pair C2 and C3, and C4. The protocol can execute either C1, C2, C3, C4, or C1, C4, C2, C3, which both respect conflicts. So the previous figure illustrated dependency ordering. Figure 3 shows how a command gets committed in 2 rounds. The initial coordinator broadcasts pre-accept with its dependency guess, replicas extend it with local conflicts, and send pre-accept OK. If a fast quorum of size n-e replies with the exact same dependencies, the coordinator commits immediately, which gives the to-message fast path. Otherwise, the coordinator moves to accept and then commits after a quorum, so progress remains F-resilient. Okay, the previous figure covered the commit protocol. Figure 4 illustrates a complete 5-process run under conflicts. The left timeline shows command C, starting at process P1, collecting identical dependencies from a fast quorum, and committing immediately. The bottom lane shows command C prime taking the slow path through accept and commit because replies diverge. The right sequence shows command C double prime entering recovery, where validate confirms safety before a new accept, so execution remains F-resilient despite failures. Alright, the previous figure showed a full run, including a recovery handoff. Figure 5 outlines the recovery protocol that a new coordinator runs, starting with recover and recover OK to gather state from a quorum. The key addition is the validation phase, which checks whether a fast decision could have happened, so proposals do not resurrect unsafe dependencies. The code then either recommits, reaccepts, or issues a NOP with empty dependencies to preserve safety and liveness. So 2 takeaways stand out. EPaxos star simplifies recovery with a non-invasive validation phase that prevents unsafe decisions, and it proves optimal fast and resilient operation while preserving the to-message fast path. The broader implication is safer, lower latency, leaderless replication that real systems can adopt with confidence. That is it for this episode of the AI Research Roundup. I am Alex. Thanks for listening.